Hey everyone, today I'm going to show you how to use React Query. This is a library that allows you to handle the kind of global state that should be synchronized with the backend in your application. In this video, I'm going to show you how to build a simple to-do application where you can create new to-dos, test, add to-do. We can load more. It works with pagination. So initially it loads only 2 items and then we can load more and then load more. We can uncheck the items, and as you can see, it happens immediately, even though we have to update the data on the backend, and we do it using optimistic updates. I'm going to show you in the end of this tutorial how to do this as well. And if you click delete, for example, it doesn't have optimistic update, so it takes some time when you delete the item, and then it queries the backend, and then it refetches the items. For this example, I use Airtable as a backend. So we can actually add the to-do items here, new to-do item, and we can probably remove a bunch of records from it. And then if we go to the application, it will automatically refetch the data because React Query automatically refetches the data when you refocus that tab with your application, which is quite handy. So let's start by creating a new React application. I'm going to generate a new app using npx create React app, React Query tutorial. We'll have to wait a little bit. After it's done, we go to the application folder, React Query tutorial. Open the code. We'll also need to install React Query, yarn add React Query. And I'm also going to copy the .env file where I store my Airtable key. cp rq to-do.env to the root of our project. Let's close this panel, go to src, and first we'll remove all the layout. Now to fetch the data inside of your React component, you would probably use useEffect and a bunch of states to hold the status of this fetching process, like is loading flag, is error, and maybe an error object, and the data that you're fetching from the backend. With React Query, you don't need to do all that. You can just use the useQuery hook to get the data, error, is loading, is error, flags, and the error object. And then you call useQuery. And then you need to pass a unique identifier of this query. In our case, it's going to be to-dos. And then you pass the fetching function. The only requirement for this function is that it returns something thenable, like a promise. So it's very good for testing because you can easily substitute the real fetching function with a fake one. And also, if you want, you can later transition to GraphQL. If you open React Query documentation, you will see that they even have an example using GraphQL request that can create the request to a GraphQL server for you. But let's get back to the code. We need to define a function that will fetch the to-dos from the Airtable. I usually create a new module called api.js that holds all the fetching functions for my application. This way it's easier to refactor later, and I'm not bound to specific fetching mechanism. Here I first need to define the data specific to my Airtable. I'm going to copy it from the previous project and paste it here. It contains the base, the table, the view, and the API URL. We are going to use it to create the fetching URLs. We'll also need a constant to hold the authentication header. I generate it as an object literal, with the authorization header, which is bearer plus the information from the environment that I take from the .env. In Create React App generated applications, if you want to use environment variables, you need to use the React App prefix before their name. So in my case, it's React App Airtable token, and it will be loaded to the environment automatically when we build our application. Now let's create a function called fetch to-dos and export it. Export const fetch to-dos equals. We need to get a key. We're not going to use it in our function, but React Query will send it anyway. And then we define a function that will fetch our data. First, we need to define the URL. I'm going to use a template string and combine the API URL with the base name, the name of my database, the table name, and also I'm going to pass a query parameter with the view ID. Now we return fetch. I pass in the URL here. It's a basic GET request, so we don't need to send anything else. except for the authentication headers. I pass an object with the field headers, and here I pass another object literal with the destructured auth header object. After we got the data, we call then response, and then we're gonna parse it as a JSON, res JSON. And that's it. We can go back to app.js, pass in the fetch to-dos. Now we need to process the loading state. If is loading, then return a paragraph that says loading. Then we handle the error state. If is error, we return a paragraph with the error value. And we should use return here as well. And then we can render the layout. So I'm going to render an unordered list, UL, where I'm going to map through data records. And for each record, I'm going to do the following. I'm going to return a list item with the key that will be record ID and text record fields text. Now let's open our application, yarn start. Oh, and I've defined the error object twice. So let's go back, remove this error from here, and go back to the browser. Now we can see the to-do items. Let's go to the application styles and position them in the center of the screen. Go to index.css. First, we're gonna add display flags to the body, align items center, justify content center. We also need to specify height for height 100% for body and HTML. HTML, body, height 100%. Let's open the app. Now everything is centered. Next thing we're going to do, we're going to add the pagination to our app. Let's go back, and to do this, we're going to need to use another hook. Instead of useQuery, we're going to use infinite query. So let's remove this useQuery, use infinite query, and it has a little bit different API. The idea is that when you use the pagination, then with every response you also get a cursor that you can use to fetch more data for your application. Airtable supports this functionality, and with each response, if you specify the amount of items per view that is less than total amount of items that you have, it will also send a cursor variable. So let's do it in the API first. We'll need to define a query parameter called page size. Page size equals, and here I'm going to use another placeholder, and for now I'm going to use 2. Now we'll also have to process the cursor variable or attribute in our function. Cursor, and then we check. If we have cursor passed in our fetch-to-dos function, then we also append the offset to our URL. URL equals URL plus template string, and offset equals cursor. And then otherwise the function stays the same. Then we go to app.js, and now we should also pass an options object with the field get fetch more. This function will get this cursor value from the data, and also it will tell you if you can actually fetch more. For example, let's use the last group name for the argument for this function. It's going to check the value of this last group, basically the last fetching response, check if it has the offset field, and then just return it. So if the last fetch response had the offset field, it will use its value. Or if it's falsy, for example, it's undefined, then the can fetch more value that you can get from this hook, can fetch more, will be false. So let's add a button to our layout so that will fetch more data when we click on it. Let's add a div that will hold the button, a button itself, and on click, it should call a function where we'll call the fetch more function that we can also get from the use infinite query. Fetch more. Now, if we cannot fetch more, let's disable this button. So the attribute disabled should be not can fetch more, or if we are already fetching more data, is fetching more. And we also get this flag from the useInfinite query, is fetching more. Let's format the document. And now let's specify the text of this button. Here, depending on the status, for example, if is fetching more, then we say loading more. Otherwise, if we can fetch more, then we say load more. Otherwise, if we cannot fetch more, then we say nothing to load. And then we format the document. Let's open the app. And here, as you can see, the data that we're getting is now different. We're getting an array of groups. So every time you fetch more, instead of appending it to the previous request, you just have a growing array of request results. Let's go back. And for now, let's just log the data and see how should we handle it. Console log data. Let's open the console. And here is our fetched data. So it's an array, and then inside of it we have the responses. Let's go back, remove this log. So now we'll need to have another loop. So we're gonna map through the data map, and for each group and its index, we're gonna do the following. We're gonna have a React fragment with key equals I, and then inside of it, we're gonna map through the records of the group. Let's format the document and go back to the browser. Okay, now we have two first items. We can click load more and load more items from the Airtable. And if there is nothing to load, we see this as a text on the button, nothing to load. Next, we want to be able to add new items. Go back to the code and create a new component. By the way, we can remove this app test.js. It's not working anyway. Create new component called add todo.js, import React from React, and then export and define a component, add todo. It's a functional component. And for now, let's just return an empty fragment. So React Query API is very similar to React Apollo, I would say. If you open the React Query documentation, you will see that it has the same concept of queries to fetch the data and mutations to change the data, to update the data on the backend, the same way as it works in GraphQL. But instead of GraphQL server, you're talking to REST API. So here we'll need to create our first mutation. But before that, let's create a layout. Here we want to have a horizontal line separating this component from the rest, from the list of the items. You want to have an input. I'm going to use an uncontrolled input, so I'm going to use a ref to get the value from it. And I'm going to create the ref to hold it. Input ref equals use ref. And then I pass it as a ref to the input ref. We want to close the input tag. And we want to have a button that's going to say add to do. And on click, we want to call the onAdd function, const onAdd. And here we'll call our mutation in this onAdd function. But before, we need to define this mutation. Const mutate add. You can use any name because it's an array item that you get by destructuring the array of arguments from the useMutation query. Use mutation. And here we need to pass only the mutating function, create to do. Let's define this create to do in the api.js module. Export const create to do equals. We need to know the fields like text and checked, unchecked. In our case, it's going to be only one field, but it's better to just send all the fields that we want to from the client. So we'll have one argument, fields. That's going to be an object containing all the fields of the newly created to-do item. And inside of it, we are going to construct the URL. It's going to be a template string again that we get by using API URL / database name slash table name, and then we return fetch to this URL, and then we pass an options object. First, we need to define the method. When we create a new item, we have to use the post method. Method post. We want to send the headers. First one is authentication header, and then we also need to specify the content type. Content type application JSON. And then we need to pass the body of the request, where we send all the fields of our to-do item that we want to create. So the field is body, and the value is JSON stringify the object with the field called fields. That will have the value of this fields argument. Format the document, go back to add to-do. Let's import the create to-do from the API. And then when we call onAdd, we want to call the mutate function with the value text input ref current value. And we also want to reset the input value. We do it using input ref current value equals empty string. Let's go to app.js and add our add to do component. Save the file, go back to the browser, and let's try adding new items. Blah blah, add to do, load more. If we open the table, you will see that our item is created, but we don't see it in the updated application. Now when we reload the page, it was added to the app. So how can we force refetch the information when we mutate the data on the backend? You do it using the query cache object. Let's go back to the code, open add to do, get the query cache, const query cache equals use query cache. And now we want to add an options object to the use mutation call and pass on success function. So when the mutation will be performed, we're gonna call a function that will call query cache, invalidate queries. And in our case, the query's name is to-dos. So we want to refetch the to-dos query in the app.js. So we invalidate to-dos and it's gonna be refetched. Let's open the browser again. I'm gonna go to to-do app and remove this empty record from here. Let's go to the app, reload the page, and try adding a new item like 1, 2, 3, 4, 5. Add to do, load more, and it should be somewhere in the list. Let's try adding another one with some random numbers, add to do, and it was automatically fetched even before I clicked the load more button. Now we want to edit the items. For example, to be able to uncheck the checkbox and to be able to remove the edit item from the list. Let's go back to the code, and we'll need to create a component to represent the to-do item. Let's create a new file and call it to-do item.js. Import React from React and export a component called to-do item that should get ID, text, and completed status from the props. Now inside of this component we return some layout. It will actually be a list item. Inside of it there will be a span that will say text. We'll also need a checkbox. It will be an input, type checkbox, on change should equal on check. We'll define this function a bit later. And checked status should be double exclamation mark to convert it to Boolean and complete it. Let's format the document and add a button that will allow us to remove this item. It will say delete, and on click it should call the remove function. Now, to be able to remove the item, we'll need to create a mutation. First we define the remove function. It's an arrow function, and then we define a mutation. Mutate delete equals use mutation. We'll use a delete to do function that we'll define in the API module, and we need to pass some options. For example, we need to refetch the to-dos when we successfully delete the item. So on success equals a function that should clean up the query cache. Let's get it using the useQuery cache hook. Const query cache equals useQuery cache. and then we call query cache invalidate queries called to-dos. Now we can call the mutate delete inside of the remove function. We call mutate delete with ID. And let's go to api.js and define the deletion function. Export const delete to do. It should receive the ID of the item. And then we construct the URL, a template string that will get the API URL slash base name slash table name slash ID. And now we call the delete method. Return fetch URL method delete headers, and we need to pass the authentication header. Destructure the auth header object, and that should be it. Let's make sure that we import this API method delete to do. Now let's go to app.js, and instead of the list item, let's use the to do item here. Let's destructure the record. We know that it has ID and fields. Then we can pass the key ID, the ID prop. That should also be ID, because we need to have the ID of the item to be able to remove it. Here we get it from the props inside of the to-do item. And then we can actually pass all other fields. We do it like this. Destructure fields, and pass whatever items we have in the fields argument. Now we can go back to the browser. To-do item on check is not defined. Okay, I forgot to define this method. Let's define const on check. It's a function. For now, it's not going to do anything. Okay, can we remove an item? Delete. And nothing happens. If I open the terminal, I see that I made a typo with onClick. Let's fix it. The L should be small. Let's go back. Close the console, delete the first item, boom, it works. Now let's add the check on check functionality. Let's define another mutation, const mutate check equals use mutation. We'll define the update to do in the API, and we need to pass an options object with the onSuccess field. Here we'll do the same, just like we did for mutate delete. We'll call query cache invalidate queries, and we needed to refetch the to-dos query. Now inside of the onCheck function, we call mutate check, and we pass an object with ID and fields where completed equals event target. We need to get the event from as an argument to the function. Event target checked. We need to wrap it into curly brackets and format the document. Now let's go to api.js and define this function that will update the items for us. Export const update to do equals a function. We need to know the ID and fields. Now we construct the URL. Const URL equals a template string with the API URL slash base slash table slash ID. And then we return fetch URL and an options object. The method should be patch, because we update the specific record. We need to specify the headers. Of course, we'll need to pass the authorization header, but also we need to pass the content type, because we're sending the data. Content type equals application JSON. And then we need to define the body. Body is JSON stringify, and we stringify the fields, just like we did when we created a new item. This should be fields, and now everything should be fine. Let's go back to the to-do item and make sure that we import the update to do function. Let's open the browser, check the blah blah to do item, and it works, but between the click, like now click, and the update, there is a significant delay that probably would be annoying to our users. So what we can do here is we can use optimistic update. So we can update the status on the client inside of the query, like manually change the cached value, and then it will still automatically perform the request to the server and then get the actual data and invalidate the previous change if it was wrong and there was some error. So how can you do this? Let's go back to the code, and we'll have to update the mutate check function. Instead of using the onSuccess callback, we'll use 3 other callbacks. First one is onMutate. So this callback will be called when we trigger the mutation, but before the data is sent to the backend. It's going to be a function that will receive the new to-do item, the updated value. Inside of it, we need to conceal all the other queries related to it. Query cache, conceal queries, to-dos. So if we are fetching anything, we need to just conceal it immediately. And then we need to get the previous state of this query, const previous query equals, here's a typo, query cache get query data to-dos. So we get the current state and then we need to update it. We do it by calling query cache set query data for to-dos, and we pass in the function with old query, and then inside of it we do the following. We return an old query where we map over the groups. You remember that we have groups of responses there, and for each group we return an object with this group value, but for the records we map through the group records, and for each record we do the following. If record ID equals new to-do ID, so if it's the item that we are trying to update, then we return a new object created from the old record plus the fields from the record fields merged with the new to-do fields. So we merge the previous fields of the to-do item with the new one, so we can update fields one by one. Otherwise, if it doesn't match, then we just return an old record without updating it. After we do all that, we need to specify the cleanup function, the function that will be called if we need to revert the changes. Return a function, query cache, set query data, to-dos, and then we just set it to the previous query. So we basically conceal all the changes that we just made if something goes wrong. Then we need to specify the onError callback, and here there will be a function that receives the error object, the new to-do item, the item that we're trying to update, and the rollback function. And we just call the rollback. Then we need to specify the onSettled callback when everything went as expected. And here we'll just reset the to-dos query cache. New to-do, and here we query cache invalidate queries to-dos, and that's it. Now let's go to the browser and try to check and uncheck the checkboxes. As you can see, everything works fast now because we are manually updating the data in the cache. And if we reload the page, the data will still be valid, updated. Let's see if we can still remove the items. We can indeed remove them. And actually React Query can do much more. You can conceal the queries, you can prefetch the data if you need it, you can disable or pause queries, it can refetch the data on window focus, you can use it with server-side rendering and a lot more. So I encourage you to just read the documentation, and it's super cool. It supports TypeScript, and you can even use it with GraphQL, and here is the example using the GraphQL request, as I said in the beginning. So thank you for watching. Let me know in the comments what else would you like to know about React Query. Maybe you want to know how to test the applications where you have it, or maybe you want to have a more comprehensive example of it. So if you're interested, just let me know in the comments or join my Discord server. The link for it will be in the description. Thank you for watching and see you next time.